my dear children. Once again, welcome to our physics class. How are you all? Hope you all are fine over there. Children, in the previous session, we had discussed about vector addition analytical method. Also, we discussed about the position vector and displacement vector in terms of I and j unit vectors. Today, we are going to discuss the most important concept of this chapter, that is projectile motion. So what do you mean by a projectile? Any object that is projected into air is a projectile because such an object will be completely under the influence of a gravity. Okay, so any object that is being projected and under flight can be considered as a projectile, and the motion of the projectile is projectile motion. So today in this session we are going to study about the projectile motion. Most important aspects are related with the projectile motion, and we are going to discuss all those aspects of projectile motion. Also, we are going to derive an expression for all those aspects. Okay children, so let's get started with this session.
Let's continue with the lesson motion in a plane. As discussed in our introductory video, we are going to discuss a new concept, that is projectile motion today. So, as an application of ideas developed in the previous sections, we consider the motion of a projectile. So, what do you mean by projectile? A projectile is an object upon which the only force acting is gravity. Also, here you can see another definition. A projectile is any object that, once projected or dropped, continues in motion by its own inertia and is influenced only by the downward force of gravity. Okay, and which are the examples of projectile motion? An object dropped from rest is a projectile. Suppose you drop a stone from a particular height. It will be a projectile motion because the motion of the stone is completely under the influence of gravity. An object that is thrown vertically upward is also a projectile. Suppose you throw a ball vertically upwards, it will be a projectile motion. An object which is thrown upward at an angle to the horizontal is also a projectile. If you project something or if you throw something not vertically, not horizontally, but at a certain angle with respect to ground, it will also it can be also considered as a projectile motion. Okay, and so what is a projectile? A projectile means an object that is in flight after being thrown or projected. Okay, it can be a football, a cricket ball, or baseball, or any other subject. Even the bullet fired from a gun can be considered as a projectile. Okay, so the motion executed by the bullet can be considered as the projectile motion. See, here are some of the examples of projectile motion. See, this ball drops something, it may be a stone, to the ground, so it is a projectile motion. And in this case, the boy throws a stone vertically upwards, so this is a projectile motion. And on reaching the maximum height, the stone returns to ground. Okay, so here the boy has projected the same thing at a certain angle with respect to ground. So this is the ground and he projects something at an angle with respect to ground. So the stone reaches the maximum height. This is the maximum height, and after reaching the maximum height, it returns to ground under the influence of gravity. Okay, so these three types of motion are best examples for projectile motion. So what are the important characteristics of a projectile motion? Here on the screen you can see a graph. This is x-axis, this is y-axis. Okay, now this is a projectile. See, this is the object, and object has been projected with a certain angle theta with respect to ground. So this is the angle theta, and this is the path of the projectile, a parabolic path. Okay, so this is the path of the projectile. Now, what will be the velocity vector? You know, The velocity vector is obtained by drawing a tangent to the curve. So here it is a curved path. So in order to find out the velocity of the object, just draw a tangent to the curved path. Okay, so let this be the tangent and this is the velocity vector of the projectile. And of course this is a vector, so we can resolve this vector into two components. Okay, how will you resolve the vector into two components? For that, draw two normals, one towards the x-axis and another towards the y-axis. Then this is the origin, so this will be our x component. Let the x component be denoted as ux, and this will be our y component. Let the y component be denoted by uy, and let the velocity by u, not v, let it be u. Okay, so the velocity vector u has been resolved into two mutually perpendicular components. See, ux and uy are mutually perpendicular to each other. Okay, what is ux and what is uy? You must find out the value of ux and uy. What is ux? Okay, if you consider the right angle triangle, see, this forms a right angle triangle, isn't it? So which is the adjacent side of this right angle triangle? Ux. And which is the hypotenuse? Hypotenuse is vector u. So find out cos theta. What is cos theta? Cos theta is adjacent side by hypotenuse. Adjacent side is ux, hypotenuse is u. So ux will be equal to u cos theta. So what is ux? Ux is u cos theta. Then what will be uy? Uy will be equal to u sin theta, because the ui is opposite to theta, because this side is opposite to theta and this side is parallel to uy. So uy is equal to u sin theta. Okay, so ux is our horizontal component and uy is our vertical component. So horizontal component is ux equal to u cos theta, vertical component is uy is equal to u sin theta. And in a projectile motion, u cos theta remains same, but u sin theta at first decreases, reaches 0 at maximum height, and then increases in downward direction. Okay, so this is about the components in projectile motion. So this is our horizontal component ux, and this ux remains the same throughout the projectile motion. That means horizontal component remains the same in a projectile motion. But the vertical component, this is the vertical component. This vertical component at first, vertical component decreases, and on reaching the maximum height, this is the maximum height position. On reaching the maximum height, the vertical component of velocity will be 0. And afterwards, when it comes down, its velocity starts to increase because of the influence of gravity. The gravitational force is attracting that object, isn't it? So its velocity will increase. So this is the variation of the vertical component of velocity vector. At first decreases, and on reaching the maximum height it will be 0, and finally when it comes down it increases. Okay, you must remember this concept. These are some of the important characteristics of projectile motion. So at maximum height, the object has only the horizontal component of velocity. Why? Because the vertical component of velocity will be 0 at the maximum height. So at the maximum height position, at this position, uy is equal to 0, and ux will be u cos theta, because this ux is not going to change in the projectile motion. Okay, so let's discuss some of the important aspects of projectile motion, and also let's try to find out an expression for all those aspects. Okay, so this diagram helps you to understand the variation of ux and uy components of velocity vector. See here, at this point, ux is u cos theta, uy is u sin theta. And on reaching the maximum height, uy becomes 0, but ux will be the same, u cos theta. And on reaching here, that means in the downward motion, ux is u cos theta, again it will be the same, and uy is minus u sin theta. Why? Because it is in the opposite direction now. Here when it goes upward, it is u sin theta. When it comes downward, it will be minus u sin theta. Okay.